So, geotrig, lesson 28 is the outline. We did 29, I think, already. We're now coming back to 28. So we got the unit circle stuff out of the way for now. But today we're going to talk about factorial notation. And factorial notation is just a way for us to multiply or to write down multiplication of numbers in succeeding order. So the exclamation point is read as factorial, and it's the product of succeeding factors where 1 is the last factor. So if we talk about 5 factorial, that's read 5 factorial, it means 5 times 4 times 3 times 2 times 1. So you just have to multiply them out. 5 times 4 is 20, and 20 times 3, 60 times 2 is times 1, so it's 120. And that's as easy as it can be. That's not the whole lesson. Now, we also have this really cool button on our calculator that can do that for us. So there's obviously several different types of calculators, and they're all going to be in different spots. So if you take your calculator out, now there's going to be times, guys, where using your calculator is going to be helpful, and other times where it's going to be more of a pain to use your calculator, or it's going to tell you don't use your calculator. At that point, maybe you'd only use it to back yourself up to make sure you're doing it right. Make sure I want to see all the work. We'll go over those types of problems. If you have the gray box calculator, the old standard scientific one that I think you guys have to use in ICP, it's actually underneath your 3 button. So if you hit second, you have to put your number in first, so like 5, second 3, which is the exclamation point, you should get 120. So try that. Or, like on the bottom there, try on your calculator, 8 factorial, do you get 40,320? If you are on one of the colored calculators by Texas Instrument, the TIs, you need to go to the PRB button. And if you hit that button, then you just have to scroll, I think, to the right twice. PRB should be on the top left somewhere. Kind of close to your second button. Okay? Then you got to put your number in. Then you can put that after it. Then you can hit enter.
It's in domain error. Yeah.
Get there in a second. And if you're on a graphing calculator, you have to hit math first, which is on the far left. And then you will go to the right about 4 spaces to the PRB section. And then I think it's like the second or third one down. So everybody test it out with 8 factorial. So let's not use our calculator. Let's actually evaluate those 2 problems first. I'm actually going to zoom those in a little bit. So, we got them changed now. Guys, without a calculator, I want you guys to evaluate these. I'm going to show you how to do that because it's a little easier without a calculator, or it can be very easy. Now, this is how it works. 9 factorial means what? No. Right, it's 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Obviously the 1 doesn't really mean much because you multiply by 1, it doesn't change. That is all over 3 times 2 times 1, guys, times 5 times 4 times 3 times 2 times 1. Yes? Here's the cool thing, guys. I'm dividing the stuff from the top there. Yeah. I'm going to cancel. The easiest thing to do is cancel the largest one. The largest one is 5 down. And wait a minute, what's 3 times 2? So all of that will cancel with a 6. Your answer is
987.
9 times 8 times 7. 9 times 8 is
Not 72.
72.
504.
And then 72 times 7. The 6 cancels because 3 times 2 on the bottom. How much?
504.
It's more than 154. 554, okay. 504? 504. Guys, try the second one without a calculator. Next one. Watch this.
Oh, and cancel that. Oh.
What did I do differently this time? I left it as 11 factorial because 11 factorial divided by 11 factorial is not 0 but 1. So, make it easier for yourself. And then, guys,
Stop talking.
start to pick it apart. Like 6 times 2 is 12. Or 3 times 4 is 12. So your choice, I'm going to get rid of the 6 and the 2 to get rid of the 12. Which maybe I shouldn't have, but I did. The 4 and the 14 can both be divided by 2. So it'd be 2 and this would be a 7. So on the top I have 7 times 13 over 5 times 2 times 3. Can I cancel anything else? I think 7 and 13 are definitely prime numbers. And so are 5, 2, and 3. So therefore, I just have to multiply those. 7 times 10 and 7 times 3. So that would be 70 plus 21, which is 91 over 30. No, it's 91 over 30. Do not put that in your calculator, please. Now where can I use my calculator? Now I'm going to use my calculator, guys. I want you guys, very quickly, tell me the value of 11 times 10 times 9 times 8.
Yeah, 792.
What would be the easiest way on my calculator
11 times 10 times 9 times 8.
to make this happen? What would be missing to finish that off?
The 7.
7 what?
Exclamation point.
7 factorial. But if I multiply that to the top, I would have to multiply that to the bottom, not to change it. Do you guys realize that I can say this is really over 1? And if I do 7 factorial over 7 factorial, I'm dividing 7 factorial divided by 7 factorial. That's just 1. If I multiply something by 1, it doesn't change it, right?
Yeah.
So how does this change my problem overall? Because 11 times 10 times 9 times 8 times 7 factorial actually becomes 11 factorial over 7 factorial. Take your calculator out, do 11 factorial divided by 7 factorial. You'll have an answer of 7,920.
How did we get an answer?
Part B of this lesson is called abstract rate problems, guys. Abstract rate problems. Basically, the rate problems that use letters rather than numbers to enhance understanding. So it's kind of the same lines that we've already been doing before. Kind of think of our abstract equations where we had fractions with a parentheses with more fractions inside, and then it said solve for b. And b happened to be in the very bottom of that fraction inside, and you had to work your way into there or take it out, right? You guys remember those? I'll draw one out real quick. So we had something like z over t equals 5 times a over it doesn't really matter. D over
Is this one of those
minus
things like
B over 2C. And you had to solve for like C. Remember that? Those were abstract equations. We're going to use the same idea of having just a whole bunch of letters, but you with the distance, rate, and times.
it's like that thing where you could find out.
So these problems, though, they're going back to distance equals rate times time. And what they're going to do, like I have here, is that abstract rate problems are usually worked in 3 steps. The statement of the problem defines 2 of the components, the rate, the time, or the distance, which allows the third to be calculated. So if you have rate and time, you multiply them together to get the distance. Then there's a change made in one or two components, and then it's asked to evaluate for that third component based off the new stuff. So there's 2 different ways, or not 2 different ways. There's going to be, in our way, we're going to do these problems, 2 different columns. And a lot of the times when we do these ones, as our example here, it's going to talk about people being late and then people being on time. A lot of the times that's the way these problems will work. So what I like to do is make 2 different columns, a late column and then an on time column. Something's going to change to either make them on time or to get so far in a race or within a certain amount of something. So there's something going to change. So the first example goes and says the train traveled m miles at p miles per hour and still arrived 1 hour late. How fast should the train have traveled to arrive on time? Okay, the first time around, it gives us 2 pieces of information. He's traveling m miles at p miles per hour. That's a distance and a rate. The 1 hour late, guys, does not affect how fast or how far he went or how long it took him. That is independent, because we need to know that, because the second half then says he wants to arrive on time. To arrive on time, you need to take the time from before and do what to it? Make him get there faster. To get there faster, so if it took me 10 hours to get to wherever I was going today, if I wanted to get there and I was late an hour, how long should I have taken to get there? 9. I should subtract that hour. So, this is what we're going to do. We're going to cut it down the middle here, and we're going to go say we got some time that we're late, and then we're going to be on time. I'm going to create 2 columns for this. A late column, an on time column, and in my late column, I have a distance equals a rate times time. There's a distance, there's a rate, and there's a time. And the thing about it is that there's also a distance, a rate, and a time in being on time. I'm going to first fill in the original information when I was late, or the train was late. Do we know the distance? How far did he go? M. Okay. I'm going to change colors so we can see that. We went M. I think it was miles, yes? Do we know a rate? P. So it's P. Miles per hour. Okay. And we know the 1. But the 1 doesn't necessarily tell us the time was that he got there. Because it didn't say he got there in 1 hour. He didn't say that he got there in 2 hours. It just said they were late by an hour. So that's going to be for our next column. That's where it's going to be that change. What was the time? Yes, you do.
An hour late.
No.
But on time.
How do we figure out time if we know a distance and a rate? Some of you guys may have seen this before. Distance equals rate times time. Sometimes they put it in a triangle. Why? Because we can cover up some information. We don't know the time. And so what I can do, this is not going to be the easiest to show on a video, but I can cover it up. And when I cover it up, time has kind of disappeared. What do I see? I see distance over the rate. That will equal the time. So, yeah, the time is going to be m over p. And that ends up being hours, right? So we just were able to fill in all of the original information. We know he went miles at p miles per hour and got there in m divided by p hours. Yeah? Now the question asks, well, how fast would he have to go? So maybe what's the rate if he wants to get there on time? So what doesn't change and what does change? What doesn't change? The distance. He's not changing. They didn't say he's going to go 10 miles further, which they could, but the time or the distance doesn't change, so that's still m. The time has to change though, doesn't it? It's not going to be m over p anymore. It's not 1.
R times 2.
No. What's the original time? How long did it take him? M over p. And he was late. So what do we need to do? Minus 1. Because I want to take the amount of time and I got to subtract an hour off to make him on time. He has to cover the same amount of distance in 1 hour less. And then I could go through the same idea. Now I got to find a rate. But the rate is using the same distance equals rate times time. If I cover up the rate is the distance over the time. The distance is m over p minus 1. So m over p minus 1. That's the answer. It's not in an acceptable form. First of all, that would be considered miles per hour, right? That would be my units. Why isn't that an acceptable answer right now? Why is m over p minus 1 an acceptable answer?
It's a complex fraction.
It's a complex fraction. So get rid of it. Get rid of the complex fraction. And what is the LCD? Yes, it's p. Multiply the top and the bottom by p, or multiply all of the individual pieces by p. I'm going to change colors here to a purple, so that means p gets multiplied here, here, and here. Yes?
Yep.
What happens to the two p's on the m there?
They can't.
They cancel, so I'm left with mp over m minus p. And if you want, put miles per hour so that we have labels. That is your answer. We did it. There was no numbers except for the 1, but it was all in variables. Say the boat traveled k miles in t hours and was 40 miles short of the goal when the gun went off. If the skipper tried again, how long would it take to reach the goal if she increased her rate of travel by 10 miles per hour? So notice that there's some things that are going to be staying consistent because she's going to try the whole entire race again. And we're going to increase some things. So just like before, I'm going to split it here, and we're going to say, hey, we're short, or we made the goal. Okay? I'm just labeling it 2 different ways so I can say, hey, 1 we didn't make it, 1 we did. And each one of these has distance, rate, and time. Yeah? Now, you don't have to put them in this particular order, but if you notice that when we made that triangle before, what was on top? the distance. And if I was missing the rate or the time of any one of them, I just divide them. I think it kind of sets it up for you in a way that all you have to do is to divide whatever's on top by whatever's on the one that's remaining on the bottom to fill in the blank. So it's kind of cool. How far is it going to go? K miles. Do we know how fast?
T hours.
No, we don't know how fast. We know T, right? T hours. This is what the problem has. T. And then it was 40 miles short. So we're going to put the 40 miles in here? No. We don't care. Okay. Can we find the rate? The rate is the distance divided by time. So the rate is K over T. Miles per hour. Now we have to make the goal, right? How far does she actually have to go to make the goal? She's going to go 10 miles per hour faster, but how far does she have to go first?
40 miles.
No, she does not have to go 40 miles. She has to go more than 40.
Hey.
K
Plus 40.
plus 40, because she missed the 40 miles, right? So now we have K plus 40. She has to go what she already traveled last time, plus the additional 40 to make it up. And it says, how long, so we got to find the time. It's not going to be T hours anymore. But if she's going to increase her rate by 10, so what does that mean? It's going to be whatever her old rate was, which we don't know, it's just K over T, plus 10. She's not going 10 times faster. She's going faster than it by 10 miles per hour. So it's plus 10. So time is distance divided by rate. If I really wanted to save a lot of time, I'd just do this and say, hey, look, there it is. Put a line underneath the distance and the rate. But I'm not doing that. We are actually going to write it out. So K plus 10, oh, not 10, 40 over K over T plus 10. Sets up a complex fraction. The complex fraction can be taken care of simply by multiplying the top and bottom or everything by T. Now remember, when you're doing this, you're multiplying it here and you're multiplying it here, and it's going to be distributed in, right?
Yep.
So this would be a T here and a T over here as well, because that's basically boom, 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 right? I do that because that way I can see everything that's going to cancel, and I can actually do that canceling of the T's on the K. But everything else gets to keep its T, right? So what do we get? We get KT plus 40T, sorry, that should be a little t, all over K plus 10T. And then that would be the label, hours. And that's it. Homework on lesson 28, page 195 is 1 through 2 and 6 through 12. Have a great day.